This is homework help for 4.2a and 4.3. And so the first thing we're going to start with is in the back of 4.2a, we have the integral of the square root of x, and we can undo this by undoing the power rule. This is the same as the integral of x to the 1/2 power. And the way you undo the power rule is you add 1 to the power. So it's going to be x to the 1/2 plus 1 is 1/2 plus 2/2, which is 3/2. So x to the 3/2 power is 1 higher. And then you divide by the new power. Dividing by 3/2 is the same as multiplying by 2/3. And so the integral of x to the 1/2 is 2/3 x to the 3/2. This is just one possible antiderivative of this. The general antiderivative is this plus c, because that way when you do the derivative, you get the square root of x, and the plus c goes away, and so you just get these any number we could add there would all give us this derivative. And so this is our final answer. If we wanted to rewrite it, we would put 2/3 square root of x cubed plus c. And this is the better way to write it. Let's look at some of the tricky ones below. Number 1 has the integral of a bunch of things added and subtracted together. Well, let's remember that when we're doing derivatives, if you have the derivative of a bunch of things added and subtracted together, you just do the derivative of each one. So if you have a bunch of things added together, that's the result of a bunch of separate derivatives. And so you can do the integral of each one separately. So that's what we're going to do. We'll just do each one separately. This is x to the 6th. We raise the power by 1, and we divide by the new power. So it'll be 3/6. This is minus x to the 4th, and we divide by 4. So it's 1/4. Here this will be plus x squared. We raise the power by 1. This had a power of 1. Now it's got a power of 2, and we divide by 2. And finally, the integral of -1 is negative x, because the derivative of x is 1. Lastly, we put a plus c. And again, we should simplify the 3/6 into 1/2. I'm not going to rewrite that, but you should. Number 2 is probably the hardest one of these. A couple ways to do it, but what is very bad, and I hope none of you do, is just start integrating the top divided by the bottom. Just like you couldn't do that for quotients, you can't do the derivative of the top divided by the derivative of the bottom when you're doing a derivative. You can't do that for integrals either. This is 100% wrong. If you did something like this, this is just terrible. Don't ever do that. There is no quotient rule for integrals. And so if you ever see a quotient, you need to rewrite it in some way to make it not a quotient before you do the integral. A couple ways we could do this. We could say this is x plus 1 times, this is divided by x to the 1/2. We could say that's the same as times x to the -1/2. And this multiplies, this can distribute. So we get x times x to the -1/2 plus x to the -1/2. That's what we're doing the integral of. And you need to remember your properties of exponents. When you multiply two things with the same base, you add their exponents. This has an exponent of 1, so we're doing 1 plus -1/2. So it's the integral of x to the 1/2 plus x to the -1/2. And so both of these we just do the power rule on. This will be x to the 3/2 divided by 3/2. This is x to the 1/2. That's what happens when we add 1 to it. Divided by 1/2 is the same as multiplying by 2, plus c. And again, we would rewrite this to have there not be fraction exponents. One more from this one is here it's a quotient. Again, you can't just do the integral of the top divided by the integral of the bottom. That's not a thing. There is no way to write this as without there being a quotient unless you recognize some of your trig rules. Whenever you see trig ones, you should be thinking, okay, the only way I can do this integral is if I just know the derivative of this. And so the derivatives you should know are sine. The derivative is cosine. Cosine. The derivative is negative sine. Tangent. The derivative is secant squared. Cotangent is negative cosecant squared. Secant is secant of x, tangent of x. And cosecant is negative cosecant, cotangent. These are ones we need to have memorized from the first semester. Otherwise, we can't do integrals like this. Now, this doesn't look like any of them, but we can rewrite this. If it's me, the first thing that I notice is that we've got sine of x divided by cosine of x, except the cosine is squared. I'm going to rewrite this as sine of x over cosine of x, because that's tangent. This is tangent, times there's an extra 1 over cosine of x. And now I'm going to try to rewrite this to make it maybe be one of these. These never use sines and cosines. Let's see what this is. Sine of x over cosine of x is tangent of x. 1 over cosine of x is secant of x. And so what we have is the integral of tangent of x, secant of x. And we know the thing that gives us secant of x, tangent of x. The thing that gives us that derivative is secant. So the integral is secant of x plus c, because the derivative of secant of x is tangent of x, secant of x. Okay. For both 4 and 5, obviously there's no product rule, so you need to multiply it out. 5, again, no product rule, you need to multiply it out. 7, it asks you, given the second derivative, to find the original function. So first we need to do the integral to find the first derivative. The first derivative is the antiderivative of the second derivative. And so we just do the power rule. It's x squared, we divide by 2. This is going to be x cubed. The power goes up by 1. We divide by 3. And that's the first derivative. We need a plus c here. To find the original function, we need to do the integral of this. This is going to be x cubed, divide by 3, so it's just 1. This is x to the 4th, divide by 4, so it's just 1. This c becomes c times x, and then there should be another plus c. Now, we don't want to have two c's here that are labeled the same way, because this indicates that these are the same as each other, and they don't have to be the same. So what we do is we call this c1, and this one's c2. So we're going to call this c1 up here. There are two different constants. So we end up with x cubed plus x to the 4th plus something x plus something. But these two don't have to be the same, which is why we use different constants. All right, on to, I'll just stop right there. I'll do 4.3 separately.